Hey everybody, Carl Shu from Snorkel.tv here. To all my US viewers, welcome back from your Thanksgiving break. I can tell you've been eating well. Today what we're going to be doing is showing you how to configure your TweenLite and TweenMax tweens to always run at a constant speed regardless of the amount of distance they need to travel. The dude at the bottom here has his tween set up as we typically would do with a set duration, meaning that it's always going to take him 1 second to get from point A to point B, regardless of how far he has to travel. So if he has to travel across a stage, he's going to move very quickly. If he has to travel a short distance, he's going to be moving very slow. The guy up top here, though, has a constant speed. He doesn't care how far he needs to move. He's going to take his sweet time moving a long distance or a short distance. And this type of tween is very helpful if you're building a game where maybe you have some enemies attacking. Think of Pac-Man, where the ghosts are traveling around chasing Pac-Man. They're always moving at the same speed. They're not easing in, easing out, or flying across the stage in big bursts like our dude at the bottom here is. So what we're going to do is show you that when you have tweens set up that might have this sort of variable or dynamic range they need to travel, we can set the speed to be constant. So I'm going to go to my start file here, and I'm going to do my best to get to this solution as quickly as possible. And for those of you who need more explanation, I will go into it in horrifying detail. All right, so we're going to start out with one dude on the stage, and we have some action script in here already to get him to move to wherever I click my mouse. Now, already, we're using this term constant speed, and I really want to clarify that it's constant speed regardless of distance traveled. If you're just talking about constant speed, you may be thinking no easing. Well, this tween right here has a default easing of quad ease out. The first thing I want to do is get rid of that ease out. You'll see that he very smoothly eases or slows down into position. So let's get this out of the equation really quick. Inside of my file, where I have an event listener on the stage set up to respond to a click of the mouse, you'll see I'm performing this tween here. I'm moving this dude. Well, I want to get rid of the default easing by saying let's do an ease of linear dot ease none. And in order to use the linear ease, you do have to import the easing classes. Okay, so now quickly you'll see that yes, he's moving very fast if he has to move a long distance, and he's moving very slow if he moves a short distance, but there's no easing. He does have a constant rate of speed per each tween, but depending on how long that tween is or how much distance he needs to travel, that's dictating his speed right now, and I don't like that. But now his ease is very much gone, so he's just doing a mechanical or a all right, I know those sound effects really help. So he has no easing now, so while he's tweening, he is moving at a constant speed, but if he's moving a long distance, he's going very quick, and if he's moving a short distance, he's going very slow. What I'm going to do is say, hey, every time this tween is generated, I don't want you always to take 1 second. I want to determine how long your ease is going to take based on how far you need to go and how fast I'm going to be moving you. I'm going to be using this pixels per second variable, which is going to say I want you to move 100 pixels per second. I have a function in here already commented out. And again, I'm going to go into this in a lot of detail moving forward, but I want my quick viewers to get up and running as fast as possible. And this function here is called getDuration. And what it needs to know is where my clip is going to start and where it's going to end. It's going to use those two values to figure out the total distance my clip needs to travel. And it's going to take that distance and divide it by the pixels per second, how fast it's moving. So if I'm moving 400 pixels and I'm moving at 100 pixels per second, I'm going to take that 400, divide by 100, and I'm going to get 4 seconds is going to be the length of my tween. So every time I click and the move dude function is called, instead of saying always take 1 second, I'm going to say, hey, you know what? Let's get the get duration function to do some work for me, and I'm going to pass in the current x value of the dude MC, and I'm going to pass in as my destination value wherever I clicked, and that's going to be the mouse's x position. All right, so this function is going to return a duration. So my duration is now going to be dynamic. It's going to be based on how far I need to go and how fast my clip is moving. So here is the solution. If I click over here all the way to the right, he's no longer speeding across the stage. He's moving at a constant rate, and then he abruptly stops. If I have him move just maybe a quarter of the distance, he's still always moving at the same pace. All right, I can click anywhere, and he just moves back and forth. He's not speeding up, he's not slowing down. So that's how we can use the get duration function to make our tweens always move at the same speed and have a dynamic duration. All right, so there it is. Let's talk about what the heck is happening inside of here. Well, first off, I'm using this duration variable, which is going to be running an equation that takes the destination value, subtracts the start value, and divides by the pixels per second. All right, this is a pretty standard formula for figuring out a duration when you know the distance and the speed. Let's go over to Google Chrome, and I want to show you where I got this equation from. The Green Sock forums, I gotta just say, guys, an excellent source of learning so much more that you can do with Tween Max and TweenLite, or the whole Green Sock tweening platform. And in this thread here, Jack Doyle posted the equation for getting the duration based on distance traveled and the speed that you're going to use. So what I want to do is show you a little chart that I came up with that walks you through what all these values mean, okay? And it's really going to be pretty simple for most of you guys to understand. But let's say that we have a box, this red box here, that has an x value of 100, and it's moving to an x value of 500. That's where the registration point is lined up. And let's also say that we're going to be moving at 100 pixels per second. If I want to figure out how long it's going to take to get from 100 to 500, you know, looking at the chart, I could just say, well, at 100 pixels per second, it's going to take 1 second to get here, then 2 seconds, then 3 seconds, then 4 seconds. All right, I can visually see that this span of 4 boxes is going to take me 4 seconds to get through. Well, we're not always going to have a chart to look at to figure this thing out. So what we're going to do is mathematically figure out the duration based on the distance traveled and the rate of speed. So using these two boxes as a start position and end position, we have the destination x value minus the start x value, okay? So our destination x is 500 minus 100 gives us the total distance, which is 400 pixels. 500 minus 100, 400, okay? So if I know I need to travel 400 pixels and I can only travel 100 pixels per second, I'm going to take that total distance and divide by the speed. So 400 divided by 100 gives me 4 seconds. If you need more time to study this chart, you know what you can do? You can pause this video and stare at it. Or you can go to snorkel.tv and I'll post this as an image with the post in this video. So let's dissect this action script here. You're taking a destination or an end value and subtracting the start value. That's going to give you your total distance, and then you're going to divide that by your speed, or your pixels per second. Now you'll notice that this equation is all wrapped inside of a math.absolute method. All right, what that means is that we're going to force this value to always be positive, because we don't want to end up with a negative duration. That wouldn't make much sense to TweenLite or Tween Max. Now, the way that you could get a negative value out of this equation is very common. If I'm moving from right to left, say I'm starting at 500 and I want to end up at 100. So 100 is my destination. If I take 100 and subtract 500, I'm going to get negative 400, okay? And then when I divide by 100, it's still going to be a negative number. I want my duration always to be positive, all right? TweenMax and TweenLite are going to figure out whether I'm moving from left to right based on my starting value and my ending value. So math.absolute always gives us a positive duration. All right, moving back into our action script file that we had created there. Let me just go to that frame. Oh, we're in the wrong file. Good job, Carl. Here, what you're going to see, again, is that equation placed inside of a function called getDuration. So getDuration wants to know where we're starting and where we're ending. Now, in this example, I'm using start x and destination x, and it makes sense for this project because I'm only moving left to right. But in the real world, you might just call this the start value and the end value because it might be an alpha, it might be a y value, it might be a rotation. Okay, you may not want your parameters in your functions to be hardwired into being x and y or anything else. So once we know where it's going to begin and where it's going to end, we're going to use the Jack Doyle formula here that we just discussed to figure out our duration. Then we're just tracing out where we started, where we're going to end, and what the new duration will be, and we're returning the duration. Okay? And again, whenever the tween is constructed, we're calling the getDuration function, we're passing in the current x value as our start x, and we're passing in the x of where I clicked via mouse x as my destination x. All right, so the duration is now dynamic. We'll test this movie one more time and give it a whirl. And now it's saying, you know what? I'm going to take 5 seconds to move across the stage. If I'm moving just a short distance, that tween was only 0.09 seconds. Or maybe we have a tween of 0.73 seconds or 1.92 seconds. So the whole point here is that based on the distance we need to travel, the speed at which we're traveling, we're going to generate our duration on the fly. All right, so that's it, folks. Hope you enjoyed. I love all that you've been doing. Keep up the great work, and we got a lot more fun stuff coming down the old pike.